Okay, so we're doing factoring trinomials now, but let's just kind of go back and talk about, where we are now, what we've done so far. So we've done something like this, where we had like 3x squared plus 2x, actually, you know what, I'm going to go 6x minus 9x cubed. And we were told to factor that, right? And you guys remember what that meant? That we were factoring out what's common in that case. So I'd say, okay, what's common to the numbers? And I would have said, okay, well, 3, right? So 3 is common to that, so I'd say, okay, 3. And then what's the greatest common factor of my x's here? Just x itself. And then I'd start a bracket. And then I'm going to write what's left. So I'm looking at each of these terms now and just seeing what's left. So in this case, what would be left here? You just have just x, yeah? Because 3 divided by 3 is 1. And then,
why would there just be x?
okay, so there would just be x because I went 3 divided by the 3 I took out. So it's like 1 now, or it's like canceled. And then as far as the exponents on these ones, or the variables, then it's, you subtract the exponents, right? It's like x to the 2 minus x to the 1, where it cancel those, so you'd end up with just an x.
Okay.
Yeah. And then we'd go, okay, plus, and then looking at the next one, 6 divided by the 3 we took out is 2, and then the x looks like it's just gone now. Cancels out to be 1. And then negative 9 divided by the 3 we took out is going to be negative 3. And then x squared. And then we add a bracket, right? Okay, so here's my factors. We had 3x as a factor. And we had x plus 2, like that's another factor, right? Okay, so that was one type of factoring. Now what we're going to do, and that was factoring by like pulling stuff out, right? And you guys are going to start to think that that was the easy one. Like that was the just factoring things out one way. You're going to be like those, they look really complicated, but they turn out to be pretty easy. Like, I wouldn't say easy, but you just got to be careful along the way, right? Now, what we're going to be doing is factoring something like, well, I'll show you an example. If we write down x squared plus 5x plus 6, there's actually a way to factor that out as two different binomials. So that actually ends up being, I'll just tell you what it is. That's x plus 3 times x plus 2. And there's my two different factors. And that's what we're getting to. I'm going to show you guys how to get from this to that one. And as a little bit of review, we've done the other part because I could expand this, right? Remember, if I expanded this, this would be x times x, and then x times 2, 3 times x, and then 3 times 2. Right, just doing that rainbow thing. So that would be x times x is x squared, x times 2 is positive 2x, and then 3 times x is 3x, and then 3 times 2 is 6. And then you combine those like terms, x squared plus 5x plus 6, and that's where that's that one, right? So we're actually just going to be able to go back and forth. So we can expand those out. It's like, now it's saying, how do we go from this one to the factored version of that one? Right? That's what we're going to learn in this class, is how to do that trick. Okay? All right, so hunting for patterns. So how can we figure this out? So if we look at, let's say, this one. If we were expanding out, that's the one we just did, right? And we expanded that out by saying, okay, remember how we went like x times that one and x times that one? Everyone like that step we did? Another way of writing that is like this. X times both those things. Okay? And then it'd be plus 3 times both those things, right? Which could be written like that. Okay? And then that's that factoring by grouping thing. So then you could, well, actually then we expand it all out. And you can see that we've got x squared and then 2x, 3x, and 6. And then we combine those like terms to get 5. So that's an example of that. And then you can do the same thing. This is just like different examples all the way along there, right, with different numbers. So let's look at the first pattern that we find. Can you guys see that when we did this, when we expanded it all out, the blue ones there, the x and the x, after we were done, ended up giving us x squared. So it's like x times x gave us that x squared. Same with this one, right? X and x gave us that x squared. 2x times x gave us 2x squared. 2x times 5x gave us 10x squared. Right, so that's that pattern, is those two front ones give us the number on the bottom. Okay, the next pattern that we're going to see is that the numbers, the actual constants on the end of these things, if we multiply those together, those give us the number on the end. So those give us the number on the end every time, right? Number on the end. So multiplying those. I promise this will make, like, we're going to get to the chase here, like why we're finding this. The third pattern is that these numbers, when we expanded it out, right, the 2 and the 5, or the 2 and the 3 added up to the 5 in the middle, right? 2x, or like the 2 minus 3 gave us -1 there. 4 minus 3 gave us +1. -4 minus 15 gave us -19, right? So those middle numbers give us that one. 3x minus, or plus, or like, sorry, -3 plus 3 gave us 0. Okay. Now, lastly, these two numbers in the middle here, these two numbers always multiply to the same thing as the front number and the second number. They always multiply to 6. Okay, every time. So 2 times -3 gave us -6, and 1 times -6 gave us -6. Every time. Okay, I'll put this all together here now. So now that we know that, this is gonna, yeah, this will sound a little confusing, so just bear with me. So to factor any trinomial of the form ax squared plus bx plus c, which just means like you'd put a number in there, a number in there, a number in there, we decompose bx into two terms whose coefficients have a sum of b and a product equal to a times c. Does that all make sense? No, it probably doesn't make any sense. That's fine. So guys, here is like the steps that we'd use for factoring here. But I think it's going to be, it's always a lot easier, I find, in math, just to show you an example and just kind of go through piece by piece and do it that way. So there's that. Here's some examples, so they'll kind of show you there as well. Here's some algebra tiles to show you that thing. Like I said, I'm not that big a fan of algebra tiles, so we'll just, yeah. Okay. Here is how we factor. So we want to turn this thing into something times something else. So let's do this example. Okay. So what we want to do is we want to find, so the number out front, so you can imagine there's like a 1 there. So that number out front multiplied by the number on the end, so those two together, they, and right up in the corner, they multiply to, well, in this case, 1 times 6 is 6. Okay? And then the number that we want to, well, I'll show you in a second, and then what we want to do is we want to add to that middle number. So I'd write like an a dot dot 5. Oh, sorry, the A and the M just means like multiply the 6 and add to 5 is what they're gonna stand for, yeah. Okay, then we're gonna find some numbers that multiply to 6 and add to 5. So the best way to do this is probably to figure out, okay, what are some numbers that multiply to 6? So it could be, yeah, it could be 6 and 1. So you might say that, like, okay, 6 and 1. But then 6 and 1 don't add up to 5, right? Like positive 6 and positive 1, that would add up to 7. Okay, so 6 and 1 can't be it. So it's not that one. But then somebody else said it. What else? What about 2 and 3? The numbers 2 and 3, they multiply to 6 and they add to 5. Okay, so those are our numbers. And what we want to do with those numbers is we're going to rewrite the middle term, the 5x, as 2x and 3x. So here, so we're going to rewrite this thing now. So we're going to rewrite this as x squared. And then instead of a 5x, we're going to use the 2 and the 3. So we're going to write that as plus 2x plus 3x plus 6. And then for reference, where we are right now, right? You don't need to scroll up, but if you want to know what we just did there, we are at, like when we were doing these questions up here, we are at like this point. Do you guys kind of see we're at the point where it's expanded out there now? So it's like we started here and we rewrote it now like that. Okay, so we're just kind of going backwards now. Yeah, so we rewrote it like that. And then the next thing that we're going to want to do is we're going to want to rewrite it like this for a second, like that top one, right? That'll be like the next step. And then we're going to end up at the top again. So let's go back here. So we're at that point. We've got it written out. Now, this is that first unit. Remember how we had that factor by grouping thing that we did in the first lesson there? We're going to pull that out again. So we're going to factor by grouping. So what we're going to do is we're going to just factor that part on its own and just factor that part on its own. All right, so that front part, what's common to x squared and 2x? Just x, right? So we're going to factor out an x. We're going to take an x out, so we're going to write just x and then bracket. And then what do we got left? We'll have x plus 2. Everyone's good with that, with the factoring out thing? Okay, now we're going to do the next part. So what's common to 3x plus 6? 3. So we're gonna factor out and in this part you have to factor out a positive 3, so it'd be like plus 3 there. And then start a bracket and you'd be left with x plus 2. Yeah, careful because we factored out the 3, so it'd be 6 divided by the 3, so then we're left with 2 there. Yeah. Okay, at this point, if one of those showed up twice, you know you did it right. Right? If they're not the same, then it's not gonna. It won't be right. You didn't factor properly. Okay. So now the answer is staring us in the face. One of our factors is the one that shows up twice, so x plus 2, and then the other one is what's left, x plus 3. There we go. So we factored it. Just to prove it. You guys don't need to do this step if you don't want. You can, but I'm going to expand this out quickly just to remind you how this worked. This was x times x was x squared. X times 3 was 3x. 2 times x was 2x. 2 times 3 was 6. You combine your like terms and we'd have x squared plus 5x plus 6. Right? So that'd just be going back the other way again. So you just couldn't go back and forth, multiplying them out or factoring them again. Okay, now that I've done all that, tell you what, I'm going to show you guys an easier way to do that.
No.
The reason why I did that, well, the reason why I'm doing it this way in general is because if we want to factor things with a number out front, like this with this 2x squared, like these ones, we have to do it this way. That's like the way we have to do it. But when there's no number out front, we can make this simpler because we went 1 times 6, right? That 1 makes life easier. We can actually, if we get this question like x squared plus 5x plus 6, here's the easy way to do this. As soon as you get this and you've got a 1 out front and it's like something x squared, something x, and then 6 on the end, what I'm going to do is just throw my brackets down. Just throw them down to begin with. And I know that it's going to be x, like it took x times x to give me that x squared, so it's going to be an x and an x. And then I'm going to look for numbers that multiply to 6. So what numbers multiply to 6? 2 and 3. So I know one of them has to be a 2 and one of them has to be a 3. It doesn't matter which one's which, right? I could have went 2 and 3 the other way around. And then they have to add to 5, so they both got to be positive. Done. Right? One step. Or like 2 steps or whatever there, right? So that one was a lot easier. So when there's no number out, there's no number out front there, you can do it this quick and easy way. And that's probably the way you guys will do it because these are more common. But especially, well, here's the thing. Okay, I'm going to do this the easy way. Let's go. I'm just going to write my brackets. Just brackets. And I can get away with this because there's nothing out front. There's just like a 1 out front. Okay, they both get an x. X and x. And now I'm looking for numbers that multiply to 28 and add to negative 29. Okay, so numbers that multiply to 28. So what do you guys think? So you might say
9 No. 4. 4, 8, 12, 16, 24, 28. I'm confused.
Okay. Okay, so what about like 2 and 14?
Okay.
You might think that one, right? You're like, okay, 2 times 14 is, or I'll even write them in here. 2 and 14, but is there any way I can get from 2 and 14 if I'm adding to 29?
No.
No, it's not going to work. What about though? What about? I got a good idea. What about 28 and 1?
Wait, what?
Yeah. 28 1. Yeah, that's a good question. How do you get that negative? So, and I'll ask myself. I'll look at this and say, okay, how do we multiply? Right. So, how do we multiply to get a positive? Well, there's only 2 ways to multiply to a positive. They can both be positive, right? Positive times a positive gives you a positive, or a negative times a negative gives you a positive. So, what if these were both negative? -1 and -28. So then we've got -1 times -28 does give us positive 28. And -1 minus 28 gives us negative 29. There. Done. So that one is done. All right. Okay. These ones, this is another kind of a special kind. It's actually not as bad as it looks. With these ones, we can actually get away with just writing our brackets to begin with again. And again, it's because there's no like number out front here. But if I look at this, you can see that it would have been an x times an x to give me that x squared. Yeah? And how did I get this y squared? There must be a y and a y on the end of this thing. But other than that, it's all going to be the same concept. So it's going to be like x plus or minus something y. Yeah, can you see that? So we're still going to say, okay, what numbers multiply to -18 and add to -3? So start thinking of things that multiply to -18. So -18 could be, yeah, what about like 9 and, so maybe I'll go like 9 and 2. But is there any way I'm getting from 9 and 2 to 3? Like if I add 2 or subtract 2 from 9? No, like I can't get there, right? So that can't be it. What about, yeah, 6 and 3? So 6 and 3 work, right? 6 minus 3 gives me 3. So I'm in the right ballpark here. So now I need to multiply to -18 though. So the only way that you can multiply to a negative, one's got to be negative, one's got to be, yeah, exactly. So here, yeah, doesn't matter which one's negative though, right? One's got to be positive, one's got to be negative. So let's just try it out for a second. What if I made this -3 and +6? So then +6 times -3 does give me -18, so that's good. But then +6 minus 3 would have been +3. So yeah, so it's just, that's good. We just got to go the other way around, right? So we'll just switch those around. This has to be -6 and +3, right? -6 plus 3 is -3. Did that make sense? Just a lot of steps. All right. Okay, let's do, what's a good one here? Yeah, let's do the front one here. Okay, these ones, hate to break it to you, we've got to do it the hard way because that 2 out front. Yeah. Okay, so let's do this one. So we've got to go. So what do we got to do? Well, it'll be different this time. We need to actually find a number that multiplies to 2 times -4. We got to find a number that multiplies to -8. And we've got to find and those numbers, whatever they are, have to add to +7. All right, so let's find those numbers. So numbers that multiply to 8 and add to 7. So 2 and 4 maybe, but no, there's no way I'm getting from 4 and 2 to add to 7.
You can't go over 8, can you?
No. Because
It has to multiply, right?
I just did an example. I just did an example like this one. You guys are like, oh.
1, 7, and 8.
What about 1 and 8?
Or 1 and 7, or whichever one.
Yeah. So then I'd write it down and be like, okay, 8 and 1. And I got to figure out, though, like positive and negatives here, though, right? So they multiply to -8. So one's got to be positive, one's got to be negative, right? That's the only way that's going to happen. So which one has to be positive? Yeah. That's going to be positive 8 and negative 1, right? So then 8 minus 1 would give me that 7. Good? Okay. Those numbers are going to go in for there. So we're going to rewrite this thing. So this will be 2x squared. And then we're going to rewrite this as plus 8x minus, you can write 1x or just minus x, doesn't matter, 1x. And then minus 4. What's my next step? Yep, factoring by grouping. Yeah, factoring by grouping. So we're going to just factor the front part and then just factor the back part. So just factoring the front part, that would be, well, what's common to 2 and 8? 2. So that's going to be 2 and then also an x, right? And then start a bracket. And then you'd be left with x plus 4, right? 8 divided by the 2 we took out, x plus 4. Now, this one can like kind of trip people up a little bit. We got to factor out, well, I don't like that negative right there, like in the front of it when it's like minus 1. I'm going to factor out negative 1 just to get that out. So we're going to factor out negative 1. And then start a bracket. And then think about what's left. After I factored out that negative 1, that would just be x now. And then what would this be? Plus 4, yeah, because negative divided by the negative I took out, that's plus 4. And there, I know I did it right. I got the same for both of those factors, right? So then, it looks like it's confusing at this point, but my answer is staring me in the face. It's x plus 4, the one that shows up twice, and then what's left? 2x minus 1. Those are my factors. All right, just for time's sake, can you guys, well, let's skip this one for a second. Can you guys do this one? I think it'll be a little bit easier to manage. So I'll get you guys to do that right now. So just pause it, and then you guys can try that one. All right. Okay, so we got to find numbers that multiply to negative 12 and add to 1. So I'd be thinking 3 and 4. And now we got to figure out the like negative and positive part. So they got to multiply to negative 4. So I know that one's got to be negative, one's got to be positive, right? That's the only way you can multiply to a negative. So it's got to be, well, they got to add to positive 1. So the 4's got to be positive and the 3's got to be negative. That's the only way that's going to happen. So now these numbers go in for my middle term here, right? That's what makes up that x. So let's rewrite this. This will be 3x squared. And then instead of an x, we're going to write negative 3x plus 4x minus 4. Okay, so now what's my next step here? We are going to factor by grouping. So I'm going to look at this one, and I'm going to look at that one.
Does it matter if you put the negative 3?
So if you're watching the video, some people did it the other way where they had 4x out front. It won't matter. It should end up the same. So, okay, so let's keep going here. Factoring by grouping here. I'm going to factor out the front part. That's going to be 3x. I'm going to start a bracket, and I'm going to write what I got left. So what do I got left? I've got x. Ooh, and here's the question. What do I got left? Is it just x?
It's negative 1.
Yeah. We've still got minus 1, right? Because remember what we were doing here. It was like negative 3x divided by 3x, right? We've still got negative 1. We're dividing that out, not subtracting it. It's still going to be... Okay, next part. 4x minus 4. All I can factor out here is like a 1 in this case. So I'm just going to factor out like plus 1. which isn't really going to change. Oh, sorry, I'm wrong. Plus 4. I can factor out of 4. My bad. Factor out of 4. Start a bracket. And I'm left with x minus 1. So it showed up twice. I know I did it right. So we're going to be left with the one that showed up twice. So x minus 1. And then what's left? So 3x plus 4. So some of you guys might have had 3x plus 4 and then x minus 1. Those are the same thing, right? Multiplying doesn't matter on the order. Those are my two factors. Nope, we're not done.
Yes.
All right. Now, if possible, key word here, if possible, factor each trinomial.
Okay, so one of them's not possible. Because he said that, one of them, at least one of them's not possible.
Okay.
Oh my god.
Okay, so
Whoa, Ben.
first one here, let's do it. Right? We can do this one the nice and easy way. We don't have to do the whole song and dance like the last one because the number out front there is just a 1. So we can just get away with throwing down our brackets. And then first one gets an x, and the second one gets an x. And then we got to find numbers that multiply to, yeah. Yeah, well, they got to multiply to 10 and add to 7. Yeah, which is 5 and 2, or 2 and 5. Doesn't matter on the order, right? You can put them in either one. So that one, and then they're both plus.
I have become a smart child.
Okay, I can't remember which one here doesn't factor, but
So all we have to do is.
yeah. So let's do this one. So
That sounds weird.
you can't do B?
I don't think so.
Okay, let's try it. I just want you to see what it looks like when we can't. Oh shoot.
You can't not do it.
All right, so we are looking for numbers that multiply to 6. So multiply to 6 and add to -5. So what numbers multiply to 6 and add to -5?
2 and 3.
Yeah, 2 and 3.
I keep trying to do this thing.
So this one is going to work.
Wait.
Okay, so how do we multiply to a negative? Or sorry, to a positive? There's only 2 ways to do that. They can both be positive or
Both negative.
they can both be negative. That's our case. Right? -2 and -3, they would add to -5, so we're good there. We'll throw it in, so we'll rewrite this as 6x squared. And instead of a 5xy, right, this middle term, we're going to rewrite this as -2xy. And then plus, oh sorry, and then plus, I'm running out of room, sorry, minus 3xy. And then plus y squared. And then we're going to factor by grouping. So what's common here? There's going to be 2x is what we're going to take out. So there'll be 2x bracket. And then we'd be left with 3x. And then minus, it's like 1 or 1y, right? 1y or just y? Well, no, because I took the x out. It's like I factored out the x there.
Didn't you factor out the y's too?
Well, it's not common to both. It has to be common to both those terms, and it's not. So the y stays. And then this one, we're going to factor out just the y. And I'm going to factor out a -y. Because I don't like that negative out front. I'm going to take that with it. So it'll be -y. Start a bracket. And then you're going to have, and hopefully it turns out to be this, right? That's what I'm hoping for. And it does. 3x. This positive turns into a negative because we factor the negative. So -y. And the one that shows up twice, so 3x minus y, and then what's left? 2x minus y.
How did we get a -y?
This one here? Because we factored out that negative. We factored out -y right there. So then this positive y, right? Positive divided by the negative became negative. Okay? They're a little tougher when you throw that y squared in there. There's just more stuff happening. It's harder to kind of see, but it's the same process.
That was really easy.
All right, let's look at this one. So I got a feeling this is the one that won't work out.
Really? Pick the last
All right.
one.
2 times 3, we're looking for numbers that multiply to 6 and add to 7.
1 and 6.
Well, this one will work out. And add to 7.
Wait, so it will work.
Yeah, this one's going to work out too.
Oh, well.
All right.
Miss Brown, you were wrong.
All right, you guys keep going. Finish this one. Yeah, there wasn't one that didn't work out that time. If there was one that didn't factor, where you would see it would be right here. You would be trying to find numbers that multiply to 6 and add to 7, and they just wouldn't add up. It just actually wouldn't work out. So there are times when polynomials won't factor, and that would be it. So they just wouldn't work. So you guys might run into some of those when you're doing your homework, right? Okay. Before we get going, I didn't really explain, there was one other type that I want to just make sure you guys are ready for. Let's say, here, it's 1 sec. Okay, last one, guys. I want to give you a little hint here too. Okay, so here's another example. Let's say like we had 2x squared plus 4x minus 30. And then you would probably go, okay, I'm going to multiply this by 2, you know, like, and say multiply to negative 60 and all of that. We can actually make life a lot easier. We can do this one different. You always want to factor out what's common first if you can, right? Because sometimes you can make this a lot easier if we just factor something out, and then it'll be like an easier question. Yeah, 2 is common to all those numbers, right? So very first thing I'd do is I'd go 2, start a bracket, and then you'd have left is x squared plus 2x minus 15. Okay, and then that 2 just kind of hangs out there. Now my question kind of changes where I'm just going to factor that part. And we can get away with factoring this one a lot easier because the number out front is just like that 1. Right? I don't have to do the whole song and dance. So I can just say, okay, 2, and then I can just throw my brackets down. And that one gets an x, and that one gets an x. That 2 is just hanging out front. I'm just kind of like doing just this part now. Okay? And I'm looking for numbers that multiply to 15 and add to 2. So what are numbers that yeah. What are numbers that multiply to 15? 3 and 5. And 5 minus 3 is 2, so I'm in the right ballpark here. So 5 and 3. And then they have to multiply to a negative, right? So one's got to be positive, one's got to be negative. Which one's positive? The 5 has to be, right? Because 5 minus 3 is 2. So there you go. So always factor out what you can first. That just makes life easier. And the 2 just stays there. There's actually 3 factors now, if you think about it, right? There's 3 things multiplied by each other to get the answer. So when you guys are doing this, you can not do 1 if you want.
Yes.
You can work.
You can cross off 1.